Welcome to the demo of our Decentralized Freelance Marketplace Dapp. This is Kamal, and we are a two-member group. Another teammate is Cypress. This application leverages Ethereum smart contracts, a front-end React app, and also a decentralized file storage using Pinata and IPFS to create a transparent, trustless freelance platform. Let me start executing this project. So let's open a command. Let's open the command prompt. So let's start by compiling our smart contracts. npx hard hat compile. So since the contracts are already compiled, hard hat confirms that nothing to compile. Now I start by running a local hot hat Ethereum node. This provides us with 20 pre-funded accounts for testing. So let's start that. So here you can see the 20 pre-funded accounts for testing, which we will use to simulate both client and freelancer roles. Now I'll open another terminal. I then deploy the context to the local network. So let me type the command hard hat run. So we should run the deploy.js. File network. So this shows the three contracts: the escrow contract, which manages job creation, funding, delivery, and confirmation; the reputation token contract, an ERC20 token used to reward freelancers and clients for successful transactions; and dispute DAO contract, which handles decentralized dispute through voting. The deployment script outputs the addresses of each contract, which I copy into the front-end configuration so the React app can interact with them. So let me show you the configuration file. So here are the contact addresses, and this is a JSON file. Here we store the addresses. So let me start the running of the front end. So before that, we can also test the smart contracts whether they are running or not. So npx. So I run the hot hat test suites to verify all the contract functionality. This includes tests for job creation, funding, delivery submission, confirmation, dispute installation, DAO voting, and the minting and burning of the reputation tokens. All tests passes, confirm the system is working as intended. Now let's go to the client folder and run our React app. This will start our React app, the local network. So this is a React app. Now Cypress and my teammate will continue the execution.
Let me start the execution of our app. Like first of all, let's connect our client account. Yeah. In this app, I selected a client account from the dropdown and connected to the wallet. This uses the private key from the Arhat node, allowing us to sign transactions with the client. So let's create a job to the freelancer. Like let me select one of the addresses of the freelancer. Yeah. And let me specify the job amount. For example, let's say 2 ETH. And I click on the create job, which calls the escrow contract to create a new job. And the job appears in the active jobs table and with a unique ID. Now I need to fund this job. And since the job ID is one, it's already filled with one. And let me fund this job. Yeah, it says success job. Job ID one is funded. So this sends the specified ETH to the escrow contract, locking the funds in escrow. The job status will be considered as funded, and the transaction is recorded in the job history. Now, as a freelancer, now the freelancer has to submit his delivery. So let's switch to the freelancer address, freelancer account. Sorry. So we are connected to the freelancer account. So now the job of the freelancer is to submit his work to get the ETH and the reputation tokens. So let me select a file. As an example, I'm choosing this file as the work done by the freelancer to get the ETH. So let me submit the file. So once I click on the submit delivery, its status will be updating. Yeah. Now, as the freelancer, I selected the job ID and uploaded a deliverable file. When I click on the submit delivery, the file is uploaded to the IPFS through the Pinata API. So the Pinata handles the file upload and returns an IPFS hash, which is stored on-chain in the escrow contract. This ensures that the file is tamper-proof and publicly accessible via the IPFS network while keeping the blockchain data lightweight. Now a wave delivery link appears in the jobs table pointing to the IPFS hosted file. So let me click on the link. On clicking on link, we'll be getting the info that's there in the .txt file. So let me also show the .txt file. So you can see that whatever the info that is there in the .txt file will be shown when we click on the link that we got on the table. So this is it. Now since the freelancer has submitted his file, now it's the client job to confirm the delivery or to raise a dispute. Now let's switch to client wallet. So now we are switching to the client wallet. So let's say that client has satisfied with the job, whatever submission done by the freelancer. So it clicks on the confirm delivery. So you can see that the status is being updated here. You can see that the delivery confirmed and the payment released. So once the delivery is confirmed, according to the app, the freelancer will be getting some reputation tokens as success. So on connecting to the freelancer account, we can see that the token is updated from 0 to 10. So let's connect to the client account again. So let's assume a situation where the client, while reviewing the delivery, found some faults with the job. So he will be raising a dispute on whatever the file that's been submitted by the freelancer. So on clicking dispute, the dispute will be initiated. So one of the key features of this dispute is whatever the reputation tokens that were given to the freelancer account one on the confirming will be deducted automatically. So you can see that I connected to freelancer account and the reputation token balances is updated to 0 because we have raised a dispute on his submission. So let's go to the client account and let me show you the functioning of the dispute DAO. So this is not the complete, this is a demo functionality. You're not able to execute this function completely because of the time constraints. So let me give some info about this functionality. So if the client is not satisfied with the delivery, then they can initiate a dispute. The dispute is registered in the dispute DAO contract. Registered users can view open disputes in the app, cache their votes for the either party, and the vote counts are updated in the real time. This decentralized approach ensures fair, transparent resolution without a central authority. Okay, let me show you a demo of this one. Since already a dispute is raised, let me also create a demo. Yeah, this dispute created. So since the client hasn't registered as a juror, let me register him as a juror first. Yeah, and since he's the client, he will be voting to his. Now the client has cached his vote. Now let's switch to other freelancer accounts and cache the vote. We need to connect their address first before casting the vote. And we can see that there is an open dispute table mentioning the dispute ID, client address, freelancer address. We can use this one in as a future work. Since the client is the only one voted till now, it updated to 1. So now let's register freelancer as the juror. Yeah, now we can go to the freelancer. Vote cached. So let me connect to other wallets and also make another vote. So you can see that the number of votes for the clients are 2 and the number of votes for the freelancers are 1. So based upon the votes, the final escrow function will be sending the reputation tokens to the respective client or freelancer depending upon the votes they received. So if the client receives majority votes, then whatever the ETH will be funded back to the client and also the reputation tokens will be funded to client and vice versa. So as a conclusion, this demo has shown the full workflow, job job creation, funding, delivery submission with decentralized file storage via Pinata and IPFS, and delivery confirmation, reputation rewards. And as an optional, we have also showed DO-based dispute resolution. And I can say that our DApp demonstrated how blockchain technology can eliminate intermediaries, reduce fees, and build trust in freelance marketplaces through transparency and decentralization. Yeah, thank you for listening to our demo, and this is our DApp. Thank you.